Let's look at some examples of climate change that happened in the past, long before man was on Earth. And when we go back to the past, we are looking at the start of civilization right here at about 18,000 years ago. And when we look at that, we can go through ice cores to reconstruct past climates. And we're going back about from year zero, which is right now, through about 18,000 years ago. This is a temperature on the y-axis, and the dotted line is the median, which is right at about now. So we're comparing it to current temperature standards. And what we see here, about 6,000 years ago, there was a definite warming period in this area. And then before that, there was a lower temperature than our current temperatures. And during these lower temperatures, that's when we had the glaciers advance. During the warmer temperatures, especially Böhlen Odderod, the glaciers retreated and then advanced again during the Younger Dryas Age. We know this from ice cores. When we take our latest 2,000 years or so, we can expand out our look with more granularity. And we can look at half-degree Celsius measures on a more finely tuned scale. When we look at that, we are noticing that little ice age that Thomas Jefferson was talking about. He wrote about this in 1781. And look, at around 1781, yes, the temperature was increasing versus about 40 years before, or even before that when the temperature was colder. So that those comments that he had a basis in reality. And our temperature today is, of course, warming very quickly. When we look at the past 2,000 years, it's certainly above all standards. Now, we haven't looked at precipitation at all for that. We're simply looking, and this is something that you are going to find. Much of this climate change work only works on temperature, and you're going to have to dig to find out precipitation data. If we take that granularity a little bit more from 1600 to 2000, we can look at this even from 1880 through 2020. So about 140 years difference. So we're adding more granularity to the data analysis here. And what you see here is that there was a spike in 1940-ish with temperature relative to what had been known before. Well, what was happening around 1940-ish in the United States? It was an industrial production for World War II that we had never seen before. So that is why you are tending to note that those temperatures went up. Now, correspondingly, we got into World War I rather late in 1917, and look at this. The temperature seems to increase around 1917 with the war. We were only in the war for a very short time. The World War II and our work for the Allies was over a longer period of time, and guess what you're seeing there? That's a really interesting point right there with temperature. And then since about 1975 or so, that temperature has been climbing and climbing for averages. Now, we can look at feedback loops as a way to link events with the past. And I wanted to go over a little bit more about positive feedback loops and negative feedback loops so that you can feel like this link is a little bit more solid rather than circumstantial. Because remember, correlation does not predict causation. It's a very famous line in science. Again, correlation does not predict causation. And feedback loops help us to explain if the correlation might have produced a causative effect. When we talk about feedback loops, we're talking about positive feedback and negative feedback loops. Let's go over them a little bit. Positive feedback loops look at an initial change in an environment and whether or not subsequent events accelerate the change? That's a positive feedback loop. Or do subsequent events decelerate the change? That is a negative feedback loop. We're going to go over some specific examples of it. You may know of some of them already, involving water vapor and involving snow when it comes to positive feedback loops. You might have heard about some of the negative feedback loops as weathering or as water vapor again. And there's controversy about water vapor, obviously, so we're going to go through both of these to see if they can reflect on causation for us. When we talk about positive feedback loops, we look at a climate change and then events that happen after that. Do the events accelerate the initial change? Well, in this case, the initial change is warmer temperatures. And the event that happens could be increased evaporation and increased water vapor. Events that might happen and might be correlated to this initial change of warmer temps. And in fact, the increased water vapor accelerates the warmth of the atmosphere and drives it to warmer temperatures on top of it and accelerates it. So that this is a positive feedback loop of an initial climate change of warmer temperatures, leading to events that increase evaporation and increase water vapor content. So that drives the warmth of the atmosphere again, because if we have more water vapor in the atmosphere, then that will condense, and remember latent energy, as the condensation happens, it releases warmth to the atmosphere. Remember the hand warmer. When the freezing happened, it released warmth to the atmosphere. So in the same way, water vapor to condensation is a release of energy. Then liquid to solid is a release of energy to the environment. It's a warming process. Condensation is a warming process. This is a positive feedback loop with an initial change of warmer temperatures and events that lead to more evaporation. Let's give another positive feedback loop. It's called the snow albedo feedback loop. To remind you, albedo is reflectivity. So that when we talk about more albedo, we're talking about more reflectivity back to the atmosphere. And when we are talking about more reflectivity back to the atmosphere, we're generally talking about lower temperatures on the surface. Okay, because that energy has reflected back to the atmosphere. Let's see how this is a positive feedback loop. So our initial circumstance was that there was high surface albedo with a lot of snow on the ground. So our change, let's say it's the ice ages, okay? Our change was that now we've got this glacier on the ground. And then our events that happened were that there was low absorption of sunlight off of this glacier, and there was a lot of reflectivity. And so that snow tended to make sure that there was reflectivity events, and those reflectivity events moved the energy out to the atmosphere and resulted in cooler temperatures for more snow. Positive feedback loop. So more snow, more albedo, more snow. And on the other way, if you had an event where there was less snow, let's say you had a warming event in the atmosphere, then you would have lower albedo. There would be less reflectivity because there is less snow to reflect. There is more absorption of those radiant waves into the now darkened ground. And so that there is warming there, which produces less snow. So if we start with a circumstance of less snow, then that will be accelerated by less reflectivity, which will warm the ground and produce less snow. So here's two circumstances of positive feedback based on an original circumstance. This original circumstance was the Little Ice Age that came through and deposited the glacier right in Morris Plains where there was a glacier. And this is another circumstance where there had been warming, the glacier retreated, and that was also a positive feedback mechanism based on albedo. So there's two positive feedback mechanisms for you. Here's a third one. When we talk about peat bogs, we are talking about their reaction to snow on top of them. So when there is less snow, when that glacier has retreated and there is less snow, there is more of that dark peat bog exposed. When there's more of that peat bog exposed, it's going to release more methane. That methane is not going to be held and chilled under that snow. When there is more methane exposed, it absorbs more radiant energy out of the atmosphere, it warms the atmosphere, and then there's less snow. So the tundra up in the Arctic is a prime place for peat moss and peat bogs, and it's a great carbon sink. The Arctic is a great carbon sink on the basis of that. When there is less snow in the Arctic, that peat bog is exposed. When it's exposed, it releases its methane. When the methane's released, it absorbs radiant energy from the atmosphere. It's a greenhouse gas. That warms the atmosphere, so there's less snow. This is a positive feedback loop because the first circumstance was less snow. The events after that meant that it accelerated for less snow. Positive feedback loop. Now, negative feedback loops. There's some controversy here, but here's one that we can work on: water vapor and clouds and weathering. When it comes to water vapor and clouds, this is a very controversial feedback loop. You will hear many people discuss the fact, well, if we have warming, we'll have more evaporation, and then we'll have more clouds, and then we'll have more reflectivity, so we'll have cooling. So in other words, if we have warming, we'll have more water vapor, we'll have higher cloud albedo, and therefore we will have more cooling of the surface of the earth. That is often heard as a negative feedback loop so that we don't have to worry about climate change. Is it true? We're actually going to explore that a bit more during this chapter. A negative feedback loop that we know is true involves weathering. And these are silicate rocks that are involved with weathering. So, for instance, limestone. The first initial circumstance is a warmer climate, and the warmer climate leads to increased temperature and presumably increased precipitation. We're noticing a lot of hurricanes now, and increased vegetation with the warmer climate and with the increased precipitation, and that breaks down especially limestone rock, and it erodes these rocks. When these silicate rocks are eroded, they are very good at providing a carbon dioxide sink, which means that they bond with carbon dioxide and they lock it into the rocks. So erosion, especially with limestone, is a powerful carbon dioxide sink, and therefore you have increased carbon dioxide removal, and therefore you have a reduction of your initial characteristic, your initial warming, a reduction. This is a negative feedback loop. And this way we can look at feedback loops when we go and look at theories that look at events in the past and try to explain them. We'll get to that on the next video.